Oh yeah.
LabRaport's the biggest pain in the butt if you're ME.
Let's go. Alright, so there's two things we're solving for in this problem. We're solving for the impedance on this right hand side, and we're also solving for the current. So let's first solve for the impedance. Okay, so this should just be pretty easy. So when we solve for impedance, first we want to put our circuit in AC steady state, but it's already in AC steady state. So what do I mean by AC steady state? I mean we're converting all of our capacitors and our inductors into impedance form, but they already did that for us, so it's really nice. So we basically are just considering just this piece. So 4 and 6, here I'll use this nice colors. Okay, so 4 and 6 are in series, and 3 and 4 are in series. So let's combine those up. And then, oh yeah, so those are in series. So we have 4 minus J6 up top, and then on the bottom we got 3 plus J4, right? And then these two branches, once we combine them, they're going to be in parallel. So if it's hard for you to see, I'm drawing the nodes. And the reason that they're in parallel is because they share two nodes, right? So we can combine those. Oh yeah, so this is basically one element here, and then this is one element here, right, after we combine them in series. So we combine them in series, and then I'm just going to call this Z top, and then I'll call this Z bottom. And then these in parallel are just going to give me one voltage drop. So, or sorry, not one voltage drop. It's going to give me like one little box, right? So we'll just have one element here. Z top in parallel with Z bottom is going to be 4 minus J6 over 3 plus J4. 4 minus J6 plus 3 plus J4. And then if you're confused on how to do that, it's just the shorthand equation of writing resistors in parallel, right? So R equivalent is equal to R1 times R2 over R1 plus R2, right? So that's all I'm doing there. Okay, so I'm just gonna call this I'll just call this ZR. I'll call that ZR. Okay, so now that we have basically simplified everything on the left hand side, or sorry, the right hand side, let's go ahead and calculate that impedance value. So this is going to be 2 ohms. I guess here I'll just disconnect this, right? And then we'll call this ZT right here. Oh shit, I probably should not call this ZT. I'll call this ZX. Okay, so ZT. And then here's our impedance that we just calculated all at once, right? So that's just ZR. I don't know what that is, but you guys can go calculate that later, but that's how you find ZT. So ZT is going to be equal to 2 plus whatever, you know, this portion is right here. You can plug that in your calculator. Okay, so we did ZT. And then now we're pretty much done from this point. We just have to find I. So to find I, it's really easy, because we're basically going to just be left with one circuit. We're going to have this voltage source right here, 120 angle 10, and then we are going to have the impedance. So I'm just going to call this ZT, right? It's going to be whatever you find right here. Okay, so now the last thing to do is just apply KVL, right? So we do our KVL in the direction of the element we're solving for. So since I is going this way, or this way, I'm going to define my mesh current, or my KVL, in the same direction as the one I'm solving for, so I don't have to switch the sign after I'm done. Okay, so let's do our KVL. KVL, it goes into the negative terminal, so it's negative. So minus 120 angle 10 plus ZT of I equals 0, and then I is going to be equal to 120 angle 10 over the impedance of the element we just solved for earlier. Yeah, so all you have to do, calculator time. Oh, don't forget the units. Shoot, ohms, and then amperes, and then we're done. If you guys found this video helpful, do all that helpful stuff, and subscribe, dislike, all that good stuff.